Okay, my friends, so let's get some solutions to this first probability homework. The first three questions are definitely just what were you thinking during the videos. A very common answer for number one is 50-50. And I think that's really, really common for a lot of folks when they're presented with something where they have two choices. They always say 50-50. We're kind of trained in a lot of ways to say it. But it's not 50-50, and you saw later in the videos why. Just because something has two choices doesn't mean they're equally likely choices, and that was kind of the takeaway from this homework. Okay, so number four, now the idea is the chances of different sums on a pair of dice. So snake eyes, 7 and 8, and then I mentioned 8 the hard way. Snake eyes, the chance was about 3%. Technically, it's 2.8%. You'll see why down here in case you didn't already. The chance of a sum of 7 is about 17%. Or 16.7% if you want to go to a tenth. The chance of a sum of 8 is about 14%. And then I talked about 8 the hard way. And this is a fun one. I had a couple of you tell me it was 1 in 11. And I couldn't figure out where 1 in 11 was coming from. And then I had a student send me a solution. I'm going to see if I can do this. Chance of 8 the hard way. I'm going to put craps just because that's where it is. Yes, here we go. I think this may be where you got the 11% from. But you got to be careful. Just because Google bolds it doesn't mean it's right. Okay, 8 the hard way. Take the chance out. 8 the hard way. I'm going to put craps in there too, maybe. Okay, 8 the hard way is, excuse me, we got to figure out what the definition of a hard 8 in gambling. Here we go. Now, see, that's talking about craps. I want to get the definition of 8 the hard way. Here we go. By definition, we'll use CasinoNewsDaily.com. By definition, any point made up of a pair of the same numbers is the hard way. So all I was asking was, what's the chance of 8 the hard way? Well, the only way to get 8 the hard way is to get 4 and 4. That's it. So the chance of 8 the hard way is the same as I said right here, snake eyes. It's 1 in 36, or about 3%. So this, hopefully you saw that. So anyway, I think the 1 in 11 or 11% or 9% or whatever numbers you were coming up with, you got to be real careful about reading the question. There's a hard way bet, but that wasn't what I was asking about. I was asking, what's the chance you throw a pair of dice and you get 8 the hard way? And anyway, I think we just did number 8 there. Use this table to explain how you could have gotten the probability of a sum of 7. Well, all the 7s, 1, 2, 3, 4, 5, 6. There's 6 ways to get 7 out of all 36. 6 divided by 36, 1 over 6, or about 17%. So you could have gotten it right there. Okay, in this last one, I did roll a weighted die. And I offered some extra credit points here, and I'm going to open the spreadsheet here. I'm going to let this thing run a little bit while we chat. I fixed this die, and you see a pretty good image of it in the homework, and you're starting to see it kind of even out here. This blue slice here represents 1, is actually very, very much larger than the other slices. And if I let this roll long enough, it'll eventually stabilize and look just like this. And if you look at these percentages right there, 28, 14, 15, 14, 15, 15. This is twice as big as the rest, the other 4 slices. So, I just said 5. I should write the first time, the other 5 slices. So these 5 slices, 14, 14, 14, 14, 15, and then this one twice as big. And you can really see it over here in this bar graph. What I was looking for, 1 comes up more often than it should. Roughly how much more often? And I didn't realize I actually left that open for interpretation. I was looking for twice as often, but some of you said about 14 or 15% more. Either of those 100% correct, because 28 is about 14 or 15% more than any of those, and it's also about twice as big as these. So any of those would have been great. As far as the extra credits, the fun one, you have to look at how there's 2 formulas that are really going on here. Here's the first one. If B7 is 7, 1, otherwise B7. So you might want to look down at what B7 is. And this is the fun one. I made a 7-sided die down here. So in other words, I rolled a 7-sided die. Now you might say to yourself, no, you didn't. You rolled a 6-sided die. But what I did was I rolled a 7-sided die, and I had this formula say, if it comes up 7, call that a 1. If it doesn't come up 7, call it whatever it comes up as. So right now, you can see, if this is 2, that's 2. If this is 1, that's 1. If this is 2, that's 2. If this is 4, that's 4. If that's 1, that's 1. If that's 5, that's 5. 2, 2, 4, 4, 4, 4, 4, 4, 7. I goofed. I changed the formula back a little ways. Hang on one second, my awesome friends. Let me let me change it back to what it should be, which is equals B7 equals 7. Yeah. Now let's try that again. Okay. If we roll a 7 this time, it comes up a 1. But if you roll a 1, it also comes up a 1. That's how I goofed it. I rolled a 7-sided die down here, but I counted 2 of the sides as a 1. That makes a 1 twice as likely. That makes a 1 twice as likely. So every time you see a 7 down here, that 7 gets replicated by a 1 up top. Sorry about that Excel goof. I was clicking too fast and not paying attention. So that's the extra credit. You needed to mention that formula and also that formula there. The last question was probably my favorite. When picking the first egg in the Monte Carlo, it really doesn't matter if I switch eggs each trial or pick the same position every time. And then I talked about flipping coins, and there's also another story about my grandfather and playing the lottery. And I just wanted to hear your thoughts on why it doesn't matter, because it does not matter whether or not you pick the same position every single time or if you switch. More randomness does not imply better randomness in a case like that. And I just was curious to see what you all said. If anybody wants to pick my brain about that, I'd love to chat with you about it. Randomness is not the easiest thing to kind of process. But I think we got enough for now. We got enough for the first bit of probability. We got 2 more to go, and then Math 105 is in the bag. We'll catch you soon.